This is the second page to the Chapter 6 test review. Number 8 wants us to list the base of each function. If I have log of 4 and it doesn't tell me the base, anytime you have the word log and there's no base listed, your base is 10. So the button on your calculator that just says log, its base is 10. Then B, it says ln of x, which is natural log. Natural log is the same thing as saying log base e of x. The ln and then log base e are the same thing, so in this case my base is e. 3 to the x power's base is 3. Log base 2 of 3, well, I just said base 2, so my base is 2. All right, 9, 10, 11, and 12. It wants us to solve each equation. So let's start with number 9 here. To get x out of a power, I must first get whatever is taken to that power by itself. So I need to subtract 1 to both sides. Oops. So I get 12x plus 9 is going to equal 3. All right, so I have what's taken to the power that has an x up there all by itself, and I need to change this to a log. So I get log, let me change my thickness here just a little bit. So I get log base 12 of 3 equals x plus 9. Okay, and then we're still solving for x. So I need to subtract 9, but what we can do here is if you have the ability to change your base, which on graphing calculators, that is under the math function. It's usually down like in the letters, like A, way down at the bottom, where it says log base, and it'll let you change it. If it doesn't, in your calculator, you would type in log 3 divided by log 12. Okay, this equals the same thing as this. Remember, that was that change of base formula. But then to finish getting x by itself, then I have to subtract 9. And that'll be what x equals. So if I do all of this in my calculator, ending parentheses where they need to be ended, I get that x is a negative 8.56. Again, be careful with your rounding. And it does say approximate to the hundredth, so that's 2 decimal places. All right, number 10. We need to get what has the power by itself, so I need e to the 4x by itself. So I need to first subtract 9 to both sides. Okay, so I get 3e to the 4x equals 6. Then I'm going to divide by 3. So e to the 4x equals 2. Now I have what's taken to the x power by itself. So we're going to log both sides. Take a log so I can, or change this to the logarithmic form. So this is log base e of 2 equals 4x. Log base e is the same thing as saying natural log. Okay. So this is a button in your calculator, so we don't need to do a change of base formula or anything like that. But I know then to get x by itself, I have to divide by 4. So I have natural log of 2 divided by 4. Again, if it puts it in parentheses, make sure to end that parentheses before dividing. And it equals 2. So I can type all that in my calculator, and I get that x equals 0.17. Okay. Number 11. This already has the log all by itself. There's nothing outside of my log on the left side. So I can go ahead and change this to exponential form to get the x outside of my log. I know my base is 7. The power of 2 has to equal 4x plus 9. Now this is an equation we know how to solve. We can square 7, and it gets 49. The right side stayed the same. And I do 2 steps here to solve for x. I'm going to subtract the 9. And then I'm going to divide by 4, and I get x is 10. Okay, number 12. Now this one I have to condense before I try to get the x out of the log. Okay, these are both log base 3. So I'm going to have log base 3, something on the inside, still going to equal 2. But I need to simplify these, and it has a plus, which means I'm multiplying them together. So 3 times 3 is 9, and I have x squared. All right, my x squared is inside my log, so to get it out of the log, I need to change it to exponential form. So 3 squared equals 9x squared. I have to square that 3, I get 9. To get x squared by itself, I divide by 9. And I still have x squared, so I have to square root both sides. Whenever we do that, we get a plus and minus. So in this case, x is going to be the plus and minus 1. So I actually get a positive 1 and a negative 1 as my answer. All right, now, coming down to number 13, exponentials have what type of asymptote? Now remember, at the first page, I showed you some pictures where I drew on the exponential graphs. They kind of look like that, where they flatten out at the x-axis if it's a parent function. Okay, so its asymptote is going from left to right. It is horizontal. It has a horizontal asymptote. Logarithms look like this, where they have an asymptote at the y-axis, or that's going vertical. Okay, so they have a vertical asymptote. Number 15, we want to describe the transformations that happen from going, if this is my parent function, and it transforms into that function. So we want to describe the transformations. Well, there became a 2 out front. Multiplying by 2, that means I have a stretch because it is greater than 1. I have the stretch a factor of 2. Grouped in the power with x is a minus 1, so that meant it's going to move right 1. And tacked on to the end all by itself is a plus 1, just means I'm going to move up 1. Okay, and those are what happened from the parent function given to get to g of x. Now, it says, what is the equation of the asymptote in g of x? Well, this is an exponential graph, and we said it has a horizontal asymptote, which is a y equals. So remember, exponential graphs look like this. Parent function, the asymptote is at y equals 0. It's on the x-axis, but we said it moves up 1. So our asymptote has to be at y equals 1. Okay, so this is the video for the second page of the Chapter 6 test review.